multiplication. This only works for multiplication, not addition. If this was square root of 5 plus square root of 55, there's nothing we could do. All right, if there was a plus there, there's nothing you can do. But because there's a multiplication, we can rewrite it as one big square root of 5 times 55. And what do we get out if I do 5 times 55? 275. You know what the nice thing about 275? What's a nice perfect square that goes into it? 25. We can just see that with the 75 in there. That 25 probably goes into it. How many times does 25 go into it?
11.
How many? 11 times. And then we have square root of 25 is 5, square root of 11. So our first one we should have put down B, 5 square root of 11. Our next one, we have square root of 14 over 42. Now if you picked A, you did not do all of the work you needed to. A is a step in solving it, but A is not the end result. A was, I realize that 14 over 42 is not simplified. That 14 goes into both of these. No, you didn't have to do this step first. You might have multiplied the top and bottom by 14 or by 42. Doesn't matter. I'm going to simplify it first. If we do that, we're going to get out a square root of 1 over 3. Square root of 1 over 3 is not the correct answer. That's not fully simplified. You have a denominator and a square root symbol over that denominator. Because square root of 1 over 3 is square root of 1 over square root of 3. So to simplify that, you must multiply the bottom by square root of 3 and the top by square root of 3. Square root of 3 times square root of 1. What's the square root of 1?
1.
It's just 1. So you didn't have to write the square root of 1. Square root of 1 is just 1. So we have square root of 3 times square root of 1, which is square root of 3 over square root of 3 times square root of 3. Is that 9? No, it'd be 3. It'd be the square root of 9. The square root of 9 is 3. So if you're ever going to make this into 9, you got to realize that this would be the square root of 9. But the easier way is just go, it's 3. So our correct answer should have been square root of 3 over 3, which was C, which a majority of us got.
The denominator, and there was like, if you had a different number, would it matter?
What do you mean by different?
3, like say it was like 4 over 5, would it be 5 always?
And we multiply by the top and bottom by square root of 5. Yes. Whatever that denominator is, that's what we multiply the top and bottom by. Yep. So if it was square root of 4 over 5, I'd multiply the top and bottom by square root of 5. So some people won't even break it apart. They'll just know I need to multiply the top and bottom by square root. Questions on those? I told you that's going to be an element in solving our problems. This is an algebra concept, not a geometry concept. So it is on you to come see me and say, hey, I don't understand this. Because we need to do this in a lot of different problems. Because today we're moving on to the Pythagorean theorem. But before we move on to the Pythagorean theorem, what questions do we have from simplifying? Yeah. Number 7 was 9 square root of 40. So looking at 40, it sure looks like 4 would go into that, right? So I could rewrite this as 9 times the square root of 4 times the square root of 10. And I know there's not a perfect square that goes into 10, so this is the biggest one that went into this. Well, the square root of 4 is 2, so we'll have 9 times 2, square root of 10, which would be 18 square root of 10. Is that not correct on the answer guide? Oh, it should say 18 over 10. Can we double check that? Because no one said there was an error on it.
No, it says 18.
It says 18. Okay, that's correct. 18 square root of 10.
Oh, sorry.
Yeah, okay. All right. Yeah.
24.
24? All right. There's a couple different ways to do this. You could turn this into one big square root, simplify that fraction. But more likely than not, did you try to multiply the top and bottom by square root of 10? Because I'm going to go with your method. Okay, so we'll multiply the top and bottom by square root of 10. And are you okay with the fact that, see how this is square root of 8 times square root of 10? That this would turn into one big square root? So I'm kind of picturing that in my head just so I don't have to write a ton of stuff down, that it speeds it up just a little bit, that's one big square root. So I would have 3 square root of 80 over 10. Are you okay with that? Okay. Now, can you guys help me out here? Look at 80. What's the biggest perfect square that goes into 80? 4 is the biggest?
16.
16 would be the biggest. Let's try 4 real quick. Let's try 4 and say I was on the test and I thought it was 4. Well, if I broke it into 4, I'd have square root of 4 times the square root of 20. Is there a perfect square that goes into 20? Doesn't 4 go into 20? Yeah, so I meant I didn't go far enough. So 16 is probably a better bet. So let's go with your 16, because you said 16 goes into, how many times does 16 go into it? 5 times. So this would equal 3 times the square root of 16 times the square root of 5 over 10. Are we good so far? Okay, what's the square root of 16? 4. What's 4 times 3? 12. So we should have 12 square root of 5 over 10. Hey, that's pretty close, except for, see this 12 over 10 fraction here? We can simplify that to be 6 over 5. So we'll have 6 square root of 5 over 5 would be our correct answer.
Actually, I put the, it's called, when we were doing 16,
Yep.
I didn't multiply the 4, the 3.
I was going to say, it sounds like you know what you're doing. Yeah. Those little things, don't worry too much about it. Yeah, Daniel. 15. 15, we have square root of 70 times square root of 42. Is that correct? Okay, so we have square root of 70, square root of 42. So we have a couple things we could do. We could just straight up multiply them. Or we could go, so what did you do? Did you just straight up multiply them? So we can go that route. We can go that route, but maybe an easier route might have been to actually break these apart first. Like look for perfect squares that go into each individual one. Doesn't mean you can, but let's go through the way. So if you did 70 times 42, what did you come up with? 29. Say that one more time. 2940. Does that, people that did that, does that jive? Yeah. Just double checking. All right, now the nice thing is you have a calculator, right? We can go ahead and plug in numbers to see which number is going to go into it. So if we did a whole bunch of different things, let me just shortcut this because I don't want you to sit there and watch me. Maybe I can't. I don't even have this here. Yeah, this is somewhere else. What perfect square did people find went into that? And if we didn't, let's go ahead and do it now. What perfect square goes into 2940? Yeah, 49 goes into it. It sounds like it's a big endeavor to have to do this, but you only had to plug in a few numbers. You had to plug in 4, 9, 16, 36, 49. And how many times did 49 go into that? 49 goes into it 60 times? Does it go into it 60 times? Okay. All right, so that would give me 7 square root of 60. But is that my final answer? Is that the correct answer on the thing? No, that means I didn't pick the biggest perfect square, but I can keep going. I can look at 60, and is there a perfect square that goes into 60?
20.
Don't just guess. Look at your perfect squares. We have 1. Hey, so a lot of us should have had these written down so you can start practicing. And we have 1, 4, 9, 16, 36. 36 definitely doesn't go into 60. So we can go down to 16 going to... I don't see why I don't have people on calculators. Yeah, 4 goes into it. So we could break it apart into 4. Dan, is that far enough? Because I'd break it apart into 4 times whatever goes in it. All right, other questions?
What happens if you don't get it
Exactly? Well, let's say you got down to 7 square root of 60. You got most of the points. But it's like you did work, right? So I'll take off like a half point because I can go, there's one more perfect square that went into it. But you did all the right thought process. You took a big number, looked for perfect squares that went into it, and found one. That's worth most of those points. And remember, this is just a small part of a bigger puzzle piece that we're going to be doing. Other questions? Yeah. 13. I would rearrange it to be 3 times 2 times square root of 6 times square root of 3. Well, 3 times 2 is 6. Square root of 6 times square root of 3 is going to be square root of 18. Does 4 go into 18? Does 9 go into 18? Yeah, so I could break it apart into 6 times 9 times square root of 2. Square root of 9 is 3. 3 times 6 is, so we should add 18 square root of 2 for that one. Okay? All right, I need to move on. We've gone over all the big ones, but I need to move on because we got important stuff. If we have time after, we'll go through that. We're going to learn one of the biggest things you need to know for this whole semester, and that is something called the Pythagorean Theorem. The Pythagorean Theorem depends on, I guess, 2 big things. First of all, to use the Pythagorean Theorem, you must have a triangle. But more specifically, what kind of triangle is this? It's a right triangle. It's one that has 90 degrees. It's the only way that you can use the Pythagorean Theorem. You have to have a right triangle. So it says, use to find the missing sides of a right, and I'm going to box that in, triangle. So when you have a right triangle, you have a very specific side that's longer than the other, and that's our C. But let's talk about A and B first. A and B are oftentimes called the legs, but you'll hear me more predominantly call it the sides. Side A and side B. And the reason why I can call it just the side is because C is a very specific side. It's got a specific name. Does anyone remember the name for that side that's opposite your 90-degree angle? It's the longest one. It is the hypotenuse. So, more important, A and B I'll usually call the sides, because we know if I talk about a right triangle, which one are our sides. Because if I'm talking about side C, I'm going to call it the hypotenuse. So we'll call it the hypotenuse. And I'm going to put an important part about this. This will be your longest side. That's important. Because when I list 3 sides, if I list sides of a triangle and I say 11, 12, and 9, 12 would have to be the hypotenuse. That doesn't make sense. You'll find out why in a second. But the longest side always is your hypotenuse. All right, so if I have a right triangle, what you guys need to remember or memorize, has to be known, is that for any right triangle, side squared plus side squared, or A squared plus B squared, equals your hypotenuse squared, which is C squared. So A squared plus B squared equals C squared. You have to know it. If you don't know it already, you need to have it memorized. Side squared plus side squared equals hypotenuse squared. So, some examples of that. Well, it says find the value of x. Now, our job is to go, is there a right triangle? Yes. So I can use the Pythagorean theorem. I have a right triangle and I know 2 of the sides. You have to know 2 sides to use the Pythagorean theorem. So I know 2 sides. What's more specific about 9? Rather than calling it the side, I'll call it the hypotenuse. So be careful how you put this stuff in. Remember, it is A squared plus B squared equals C squared. A squared plus B squared equals C squared, where C is our hypotenuse. So in this case, one of my sides is 7. It doesn't matter if I call it my A or B. These are just placeholders for sides. So I could put the 7 here, I could put the 7 here. I'm going to put it in first. Let's go. Okay, we have 7 squared plus, and in place of the B, we're going to put the X. And that's going to equal my C squared, which is 9. So make sure you keep those squares there, though. It's messed up if you don't use those squares. Now we have to solve for x. So to solve for x, I'm going to first square the numbers I know how. 7 squared, that's 49, plus x squared equals 9 squared, which is 81. What property would I use to move the 49 to the other side if this was a proof? I would use the subtraction property of equality. So we're going to subtraction property of equality to move that 49 to the other side. So minus 49 minus 49. Is it okay if I use my calculator here? Absolutely. Just get it correct. Get it correct. So now we're going to have x squared equals, what's 81 minus 49? 32. All right, so we have 32 now. What do I need to do to both sides to get rid of this squared? Now we got to go back to algebra. Divide by square root? No. We do not divide by square root. We take the square root of. Is this a multiplication? Do I read this as x times 2? No, I read it as x squared. The inverse of x squared is square root of both sides. You're not multiplying, you're not dividing, you're taking the square root of both sides, which will look like this. So I'll do the square root of both sides. Now I'm going to throw something out there and I'm going to take it right back. When you take the square root of both sides, does anyone remember what you add in front of it? You add a plus or minus. In geometry, we don't have minuses because you can't have a negative side, so we're just going to keep the pluses. So know that in algebra, this would be plus or minus, but in our class, we'll just keep it plus. It'll be plus square root of 32. So we're going to have x equals the square root of 32. But you would not get full points for that. Why would I not get full points for that even though I did all the work correct? Because there's a perfect square of 4 that goes into this. So we have to go further. Square root of 32, 4 goes into it. So I could break it apart into the square root of 4. How many times does 4 go into 32? Which would equal 2 square root of 8. So now you might see the more important reason on why I really stress that you know how to complete or simplify square roots. Because without that, you don't get full points for this. You could have did all the steps correct, but if you don't simplify it, then you are incorrect.
Can't 16 go into... Isn't 16...
What's wrong with 8? Is it okay if I catch it there? Is it okay? Do I have to go back and do 16? I could do it here. Would it be easier if I did 16? Yeah, but I might have said, you know what? I got to here, and I thought about it, and I'm like, 8 looks weird. 8 looks like square root of 4 goes into it. So maybe I go back, and I'm like, oh, that wasn't right. That wasn't right. I did have 2 square root of 8, but that equals 2 square root of 4 times square root of 2. Square root of 4 is 2. 2 times 2 is 4. This would equal 4 square root of 2. Our correct answer would be 4 square root of 2. Probably on a test, if you got to 2 square root of 8, I'd probably give you full credit because there's just not enough for me to take points off. But know that I can take off points. All right, especially if you don't try at all. If you have a huge number still. But we tried something, and we got to 4 square root of 2. Any questions on that one? Okay, let's do the next one. Note, the next one we have a missing hypotenuse. So we're going to change our formula just a little bit. So it's side squared plus side squared equals hypotenuse squared. So one of our sides is 5 square root of 2. So we're going to have, make sure you use parentheses, 5 square root of 2 squared plus 7 squared equals x squared. So note, this time my x is on the right side. I have x squared over here. Now we have to remember how to do that 5 square root of 2. How much room do I have? Yeah, I do. So what I'm going to note is 5 squared of 2 is really 5 squared times square root of 2 squared. 5 squared, that's 25. Square root of 2 squared. Can someone raise your hand and tell me what's square root of 2 squared? Santiago? It'd be 2. So we'd have 25 times 2 plus 7 squared, which is 49, equals x squared. We'll keep going. 50, thank you. plus 49 equals x squared. And suddenly I have 99 equals x squared. I forgot. How do I get the square to the other side? Do I divide by square root? You're saying no? What was a better way to put that? Instead of say dividing by square root, what's a better way to put that? I just want us to be able to... We're going to take the square root of both sides. We're going to square root it. Don't say divide by square root. We're going to take the square root of both sides. I'm going to flip sides real quick. I'll say x equals the square root of 99. In 99, is there a perfect square that goes into 99? What was that? Probably 9 goes into it. How many times does 9 go into it? 11 times. So this is going to equal square root of 9 times square root of 11. Let's pause there. Is there a perfect square that goes into 11? Does 4 go into it? No, nothing goes into it, actually. It's just 1 and 11. So we're good. So we're going to have 3 square root of 11 is our answer. Questions on those? All right, we're going to skip the next two real quick. We're going to come back to those if we have time. You're going to do those on your own. But I'm going to skip to number 5. Number 5 says, I need to find this missing side. What if I told you, what would be wrong about this statement? What would be wrong about the statement to say, oh, to find this missing side, I'll just do 14 squared plus 15 squared equals x squared. Don't shout it out. Think about that. What's wrong with that statement? What's wrong with me, and don't write this down because this is, or you can say this is wrong. 14 squared plus 15 squared equals x squared. That is wrong. I'm going to put a big wrong on there. Why is that wrong? Yeah.
There's no right angle.
There is no, the only way I could have done that is if there was a right angle here. Did I specifically say there's a right angle there? Does it look like a right angle? Possibly, but unless I write a right angle or 9 degrees, that's incorrect. What do we... What was that?
Wait, what were you talking about on the left side?
Oh, I'm saying in order for it to be 14 squared plus 15 squared equals x squared, this would have to be a 90-degree angle because the whole triangle would have to be 90 degrees because this would be our hypotenuse. But I don't know that's a hypotenuse because no one said that's 90 degrees. What could I do instead? Yeah.
Find the missing side of the small triangle and subtract it from the big one.
Yeah, I don't think we're going to be doing any subtracting though. I think we're probably going to be doing some adding because what I'm going to do is I'm going to say, well, do you guys see this right triangle right here? Let's focus on that. Let me highlight it. I'm looking at this right triangle. And I'm also looking at this right triangle. Because you know this whole thing has to equal 180 degrees, so both of these must be 90 degrees. So I have 2 right triangles. I need to find this missing side and this missing side. Let's go ahead and call it maybe side, pick a letter. Don't pick A because we already used it. Don't pick B. Don't pick C. We already have X. Q. Tough one, but I'm okay with Q. Someone pick another letter.
Y.
W. All right, so if I find W and I find Q, we can add them together to get X. If I find W and Q, I now have X. So let's look at W. Let's find W. Well, W is a side because 14 would be our hypotenuse. So it would be W squared plus 12 squared equals 14 squared. So we'll have W squared plus 12 squared equals 14 squared. Let us continue. 12 squared, I'm going to wait for you guys to actually put in your calculator because maybe you have it memorized. But if you don't, you should be plugging these in your calculator. Don't wait for other people to do it. What is 12 squared? Don't shout it out. Raise your hand. Don't shout it out. 144. Let's check 14 squared. What's 14 squared? Someone else? Yeah. 100 and what? 96. Yeah. 196. We should subtract 144 from both sides. Will says is 52. Are we good with 52? Okay, now we're going to take the square root of both sides. I'll have W equals, is there a perfect square that goes into 52? 4 goes into it? How many times does 4 go into 52? We should all be on, you're saying 13 times. Is there a perfect square that goes into 13? No, so 4 is probably the biggest one that goes into it. So we're going to have square root of 4 times square root of 13. Our W equals 2 square root of 13. We're not done. We have to find the other one. We need to find Q. Now notice Q is also a side length. 12 is a side length. 15 is our hypotenuse. So to find that, we're going to go side squared plus side squared equals hypotenuse squared. So that would be 12 squared plus Q squared equals 15 squared. Take a second and solve for Q. Take a second and on your own, solve for Q. About this. So one more time. Our answer should have been 9 plus 2 square root of 3. All right. There's something called Pythagorean triples. Pythagorean triples, if you memorize these, can speed up specific problems. The one you should definitely have memorized is 3, 4, 5. If you see a Pythagorean triple, it requires no work as long as you have it memorized correctly. So if I told you the sides of a triangle are 3 and 4, find the hypotenuse. If it's a right triangle, it's 5. It's automatically 3, 4, 5. How did I know 5 was the hypotenuse here?
It's the C squared.
It's the C because it's the longest. Someone said it over here. It's the longest one. So if I have a 5, 12, I know the missing hypotenuse is 13. If I tell you that you have a right triangle that has 8 and a hypotenuse of 17, you go, oh, the missing side is 15. Once again, you do not have to have these memorized. If all this makes sense to you, you might want to take a second and memorize some of these. It can speed up specific problems, especially their whole numbers. Now, Pythagorean triples also get you more values. So if we read down here, if you multiply each number of a Pythagorean triple by the same whole number, the 3 numbers that result are also Pythagorean triple. I feel like that's missing letters. It's Pythagorean triple. All right, so for example, 3, 4, 5, that's Pythagorean triple. If I multiply them all by 2, 6, 8, 10, that's a Pythagorean triple. So if you notice 6 and 8, you can go, oh, 10 would work there as well. If I multiply these by 3 and have 9, 12, and 15, that's a Pythagorean triple as well. Once again, you never have to use Pythagorean triples. You can always use the Pythagorean theorem. This just speeds up, for people that have good memorization skills, it just speeds it up. Don't ever feel bad that you don't use these. Pythagorean theorem gets you the answer. And it's pretty quick, too. It doesn't take that long to do a 3, 4, 5, even if you did the Pythagorean identity. I would do a disservice if I didn't talk about those.
Yeah. So we won't even have to show work.
You wouldn't have to show work, but make sure you are correct. So, yeah, you noticed on the first one it was 6, 8. So your first homework question is 6, 8. 6, 8 pairs with 10. I don't need to see work on those. If it's a Pythagorean triple, you don't have to show me work. But don't just cheat the system. Right? Don't automatically. It's only if you could memorize it on a test. If you don't think you can, then just do it the normal way. All right. The next huge concept we're going to do with Pythagorean identity, Pythagorean theorem. The Pythagorean theorem says if a squared plus b squared equals c squared, you have a right triangle. So that's what we're going to talk about the Pythagorean theorem converse. The Pythagorean theorem says if you have a right triangle, then a squared plus b squared equals c squared. The converse is flip that. If c squared equals a squared plus b squared, notice how I just put the c squared on the other side? For some reason, we traditionally do that when we're checking the converse. This is just a squared plus b squared equals c squared. If this is true, then the triangle is right. So this is the way to check to see if you do have a right triangle. So this is going to be, I give you 3 sides. Is it a right triangle? You plug it in, either it is or it isn't right now. If it isn't a right triangle, so if it's not a right triangle, either it's an obtuse triangle or it's an acute triangle. Because to be a right triangle, it's got to be perfect. If it's not perfect, it might be obtuse, it might be acute. So you have 3 options. If I say, is this a right triangle? You might say no, but it is obtuse. It might be acute. Let's figure out how we decide if it's acute or obtuse. So our first one is, hey, if this isn't equal, maybe our c value is too big. In which case our c squared would be bigger than a squared plus b squared. If our c value, our hypotenuse is too big, if it's too big, my c value is too big, I have to open up wider, which makes it, what kind of triangle is it if it's open wider?
Obtuse.
Obtuse. So if your c squared is bigger than your a squared plus b squared, then it is obtuse. Anyone want to take a guess if our c is too small? It is what? It's going to be acute because our c value is too small. Now we do have to square them. You can't just put them up. You do have to square them. You have to assume that they're right triangles first, and then we decide after that what they are if they're not right triangle. So if c squared is less than a squared plus b squared, then it is a nice little acute triangle. How are these going to look on a quiz or a test? They're going to look exactly like what we do next. First, determine if the three side lengths could form a triangle. Recall from earlier, the sum of the two smaller sides must be greater than the third side to be a triangle. So that's what they say first. First, determine if it's even a triangle. So we go here, and we take our two smaller sides. 3 plus 7 equals 10. Is 10 bigger than the third side? 10 is bigger than 9, so we're good. It can be a triangle. So we know it can't be this one. We'll find out. So to check it, which one has to be the hypotenuse or potential hypotenuse? Has to be 9. So my 9 has to be the first thing I write down. So I'm going to go, okay, 9 squared. That's my potential c squared. Maybe I'll even mark that. That's my potential hypotenuse. That's my potential c squared. Now, I don't know if they're equal to it. So there's a couple ways you can do that. Some people put a little colon. I usually put, so you can put a colon there and say, I don't know what it is. I like to put a missing line or a question mark. Like, I don't know. I don't know if it's equal to it. That's what I'm checking. So it's something compared to 7 squared plus 3 squared. Well, 9 squared is 81. I still don't know what is compared to these. 7 squared is 49. 3 squared is 9. Is 81 equal to 58? No, it's bigger. And remember, this was our potential hypotenuse. This was our potential hypotenuse. Yeah, our potential hypotenuse is too big. If this was an equal sign, it'd be a right triangle. But because our hypotenuse, and it's always good to know which side you think is your potential hypotenuse. Your hypotenuse is too big. Your triangle must open wide, which means it has to be obtuse. Bingo, bango, dunno. Take a second. Don't shout it out. Raise your hand. Which is my potential hypotenuse here? 29, 21, or 20? Which one's our potential hypotenuse and why? Ooh, no volunteer. What was that? 841. Now help me out here. I want both of these added together. Your calculator can do both of these. You don't have to do each individual one. What happens if I plug 20 squared plus 21 squared into my calculator? So I'm doing 20 squared plus 21 squared. It equals 841. Can someone raise your hand and tell me what does it mean if they're equal to each other? Well, it's a right triangle. So this is a right triangle. All right, now we're at number 8. Before you start number 8, what do we check for first? If what? Check to see if it's a triangle. Do you remember how to check if it's a triangle? We add the small ones, 4 plus 11. So I go 4 plus 11 equals 15. Is 15 bigger than 16? No, that's false. If that's false, I'm done. We just pick not a... Do you see how easy this can be? But isn't this an easy problem to miss? Because I just fall into this trap where I just do our c squared equals or whatever, where I didn't have to do any of that work. I just had to add 2 numbers to check it. So make sure on quizzes and tests and homeworks that you're checking to first see if it's a possible triangle. Questions on any of those? All right, I'm going to give you the answers to the rest of them. I would like you to show me work supporting them. I have this one being acute. I have a right. And I have not even a triangle. So before you leave, we have, 5 minutes? I would like to see that you can prove that all that stuff is true.